In this video, we'll be looking at the basic changes to the cosine function. Very much like the sine function, it's going to also have modifications with this multiplication by a, this multiplication by b, and this addition of c. So in this case, if we recall the cosine function, the basic cosine function is going to have its period generically as 2 pi. We're going to cut that in half to get pi, cut that in half to get pi over 2, and multiply that value by 3 to get 3 pi over 2. Then we're going to make this 0 location known. We're also going to go ahead and identify a max value of 1 and a low value of negative 1. And the cosine function is going to start at the high point, go to 0, go to its low point, back to 0, and then back to its high point. Again, remembering that we have to make sure that these are nice smooth curves, almost in such a way that they're circular when we go to graph them. So this is the basic cosine function. If you recall, with the sine function we had very important pieces of information. The first piece was amplitude, the next one was period, and the last one was the phase shift. Just like the sine function, the cosine function actually has the exact same piece of information. The amplitude is the absolute value of a. The period is going to be that 2 pi, because the initial period of cosine is 2 pi, so the period formula for cosine is 2 pi divided by the absolute value of b. And then finally, the phase shift is going to be a negative c divided by b. Again, just like that of the sine function. So we've got these three pieces of information. If we want to sketch any cosine curve, we just have to be able to identify these pieces such that the amplitude is going to be your dashes on the y-axis, and your period is going to identify the last dash on your x-axis such that you follow that same pattern. Cut in half, multiply by 3, and then don't forget your zeros in there unless the phase shift is going to modify that. So for this video, we're going to go ahead and cover, to first start, negative 3 cosine of pi over 2 times x. So this is a very unique case because there's a pi inside the b value, which is going to make our period a little bit wonky. But it doesn't change how we handle this function. The first thing I'm going to do is I'm going to label my amplitude. My a, remember, is the absolute value of this. So it's the absolute value of negative 3, which makes it 3. But I have to recall that a negative out in front of any graph will force it to be flipped upside down. So I'm going to go ahead and say flip one more time vertically. I'm going to have to denote my period. Now my period, remember, is 2 pi divided by the absolute value of the b value. My b value in this case is what's multiplied by x, which is pi over 2. If I'm real careful with this is really just 2 pi divided by pi over 2. But if we don't like that notation, remember we can always change keep the first fraction, change the sign, and flip the second fraction, or KFC, in a slight different change of order. But it's 2 pi then multiplied by 2 divided by pi. In that case, the pi's will cancel out, and I'll be left with 4. This is not a bad period. Yeah, it's not going to be pleasant for us to look at it based on us learning that every single time that we play with a sine or cosine function, it's going to have some kind of pi in the x-axis. That is not always the case if there's a pi inside my function like this. Last thing I'm going to make note of is my phase shift. Notice that there's no plus c value or minus c value, and that's supposed to be negative c divided by b, in which case it's going to be 0 divided by pi over 2, but 0 divided by anything is still 0. So there is not going to be any phase shift. Again, if you're asked about the phase shift, you could say none in that particular case. So let's go ahead and graph this function. I'm going to go ahead and draw my basic same axes x and y. On that x and y axis, I'm going to go ahead and label the most important pieces. First, I'm going to label my amplitude because it's generally the easiest. That's a value of 3 and a value of negative 3. Again, graph this appropriately so that your positive values are up here and your negative values are down here. Don't take this negative as you flipping this axis. That's not what we do. Again, we draw the x and y axis as though it's any other generic x and y axis. We put the positive values on the vertical top end and the negative values on the vertical bottom end. Now, the last possible point I can plot on this, it used to be 2 pi, but that was the original period of cosine before it got modified by this particular value. In this case now, the period is actually a value of 4. That means my last value on this x-axis is 4. I'm going to cut that value in half, nice and smooth, is 2. Cut that in half, I'm going to go ahead and get 1. I'm going to multiply that value by 3, easily get 3. And then there, don't forget 0 at the beginning. And again, these should be relatively equidistant apart. It's okay if some of them, like this one here, is definitely obviously larger than this one. It's okay if there's slight modifications, but in most cases they should all be equidistant. These 5 values should be the same distance from each other. Now we have to remember the cosine function again starts at the high point, goes down, low, high, 0, low, 0, high. That's the pattern I like to memorize. High, 0, low, 0, high. But if it's flipped vertically, instead of starting at the high point, I should start at the low point. And I'm still going to go down to the 0 value, theoretically down, I'm going up, I know. And then I'm going to go to the low point, but the low point is now going to be the high point, so it's going to be up here. I'm going to go back to 0 and then back to the low point. And that's the pattern I'm going to follow for cosine, making sure that I connect all these points with a nice smooth curve. Doing my best to make sure that there's no juts or awkward occurrences in there. So that's your basic cosine curve, again, when it's modified to have a different amplitude and a different period. If we were to do one more of these examples, say y equals, let's do 1/4 cosine of 1/7 x. Now it's important for us to look at it this way, because sometimes you might see it this way, the cosine of x over 7. What's important to note is that this is the same thing as this. So the thing that you're multiplying the x by is actually a value of 1/7. So if I'm going to go through this work again, I'm going to find my amplitude. My amplitude is 1/4 because it's a positive value. My period, I'm going to go ahead and take 2 pi and I'm going to divide it by that value being multiplied by x. So I'm going to divide it by 1/7. But when I divide something by a fraction, remember that that's going to do the same thing I did up here with the key flip change, where the 2 is going to go up top and be multiplied by that 2 pi. So that's what's going to happen with here, where this changes the 2 pi to be multiplied by 7, and therefore ends up being 14 pi. My phase shift, just to make note, is still 0, and there's no modification there. So when I go to graph this function, again, I'm more or less graphing the same function here and the same function here, except for it's going to be closer to this one simply because of the graph pattern, and it's not going to be flipped upside down. So when I go to graph this function, my amplitude is going to be the 1/4 value, so 1/4 up top and a negative 1/4 at the bottom. Notice how I'm not kind of gauging the distances here. What's important here is I'm labeling it correctly. That's what's most important in terms of these graphs. Yes, we should understand that if I were to graph a different function that didn't have this 1/4, then yeah, it would go way up here. Again, if this is 1/4, that's 1/2, that's 3/4, and then way up here would be our value of 1 if I needed to plot the value of 1. But that's only in reference to if I had to see them both on the same axes. If I don't have to see them on both on the same axes, then I'm not going to worry about plotting all the extra points. I'm going to plot only the points I need. So if I plot the points I need for this one, my period is 14 pi. So that's my last value that I'm working with, is 14 pi. I'm going to cut this thing in half, and that's going to give me 7 pi. Again, cutting 14 pi in half is just dividing it by 2. I'm going to divide that by 2, and that's going to give me 7 pi divided by 2. Now don't overcomplicate this. If I'm going to multiply this value by 3, it's really just multiplying the top by 3. That's going to give me 21 pi divided by 2. And then don't forget 0 is also included in there. Now, again, if I were trying to graph a generic cosine function in accordance with this, meaning on the same set of axes, my generic cosine function would start way the heck up here, and it would finish all of its information somewhere like right around in here. Meaning it's going to be something all sorts of crazy coming down, back up, and then stop up here again in about this much distance. Because 7 pi over 2 is really like 3.5 pi. And remember, about half that distance then is 2 pi. And that's the information in which the original sine function, that's what this function is doing in that space. Okay, in just that space. But this function has a much larger period, which means it's going to take longer for it to fulfill all the values that it needs to occur, but it just won't do it in that set of values. So I'm going to start with the high point, because cosine starts high, hits 0, goes low, hits 0, and goes back to high. And I'll notice here that that should be negative. If you didn't plot that there, make sure that that's negative. It's going to go, again, nice smooth curve down like this, like this, again, trying to do my best to make sure that it's smooth curved in that format. And that's what that cosine function should look like. That's what that cosine function should look like. Now again, one more time, if you want to see it in pencil, the original cosine curve, if this is approximately 3.5, I'm going to do a little bit less than half of that distance, so that's right about there. And if this is 1/4, then I'm going to go ahead and do, that's 2/4, 3/4, and 1. I have to do the same thing down here, 2/4, 3/4, and 1. I'm going to go ahead and zoom this out just a little bit so you can see it hopefully as clear as possible. My cosine curve, this curve right here, should look something very similar to this. Starts here, curves down to hit 0, somewhere in there, curves down to hit my low point, curves back up to hit the other zero about 3/4 of the way through this distance, and then it's supposed to stop back up at its high point at that location right there. Again, that's what the actual curve of this would look like if I were to draw it in comparison to this one. So what you'd end up seeing here is that this is going to repeat itself 7 times before it hits this location. So what's important here is that if I'm asking you to graph just a single period of a given function, then you should stick to the values at hand so that the curve looks smooth, simple, and straightforward. Don't try to graph all of this information on a different type of axes. Again, trying to graph this function, for instance, down here would simply make it look like this. You'd go at 1/4, somewhere about here, and then you would see nothing more than this. Because think about it, that's what it would look like. That's all it would look like, is right there. It looked like a straight line going across until it gives down and comes back up. So again, be very, very specific about the values on the axes. What is absolutely necessary is the 5 anchor points, and then these 2 locations, and then making sure that you graph those 5 points clearly where they're supposed to be and connect them with a nice smooth curve. That is how you graph basic cosine functions with amplitude and period modifications.